Okay, so for problem number 9, we're trying to show that these things here are true, and we're dealing with a family of sets that is indexed by the set delta. And we're trying to prove statements concerning another set of indexes, which is the set gamma, that is contained in the set delta. So for item A, we're trying to show that the union over gamma of this family is a subset of the union over delta. So what we're going to do here is take some element that is here and show that element must also be here, and therefore it is a subset, right? So for item A, we're going to say, let X belong to the union. So the union over gamma of A sub A. Well, if X belongs to the union, it means then that there exists some index, some A belonging to that set, set of the indexes, such that X belongs to a particular set, right? A particular set of the family. Then there exists some A belonging to gamma such that X belongs to the set with that indexed A, right? And then we're going to say, note that gamma is a subset of delta. And so A must belong to delta. Because if A belongs to gamma and gamma is contained within delta, then A belongs to delta. So therefore, this means that thus there exists some A belonging to delta such that X belongs to A sub A, because we said that, hey, if X belongs to the union, then X belongs to A sub A, right, for some index A. And then since that index is contained in delta, then this here fulfills the definition that X belongs to the union, right? So thus X belongs to the union of A belonging to delta of A sub A. So we took some element that was in this union over gamma and then showed that it must be in the union over delta. So the conclusion is that it's going to be that the union over gamma is a subset. Therefore, the union over gamma of A sub A is a subset of the union over delta. Okay, and that is it for item A. So now we're going to do item B, and we're going to show that the intersection over delta is a subset of the intersection over gamma. So we're going to do the same idea here, where we're taking some element that is here, and then we're showing that that element must also be there. So we're going to say, let X belong to the intersection sub A. So now we're going to expand the meaning of X belonging to the intersection. Then for all the indexes belonging to this set here, X belongs to A sub A, right? And then we're going to say, note that gamma is a subset of delta, right? So what does this mean? If gamma is a subset of delta, it means that every element in gamma is also an element in delta. So thus, and since, maybe I'm going to expand it, since maybe this is overkill. So we're going to say, hey, since every element in delta X belongs to the set indexed by it, then the natural conclusion then is that for all, maybe I'm going to put so for all A belonging to gamma, X belongs to A sub A, right? So our conclusion is going to be, therefore, Therefore, since this fits the definition of the intersection over gamma, X belongs to the intersection A belonging to gamma of A sub A. Thus, if we took some X that was here and then we showed that that X must also be there, the conclusion is going to be the intersection over delta is a subset of the intersection over gamma. And that is it for problem number 9.